2.6b is inequalities, which involving the absolute value. Okay, so now we're moving into the inequalities. So no more equal signs, but less than or greater than symbols, right? All right, here we go. Your first box. In your first box, honestly, you only need to write one of these. It doesn't matter what you put in the box. It's just telling you that when we don't have time for you to write them all. Is that when you have a less than situation, it's going to produce a joint solution, right? It's going to be some type of joint solution. And you're going to be, it's this and that. Okay, so when you're solving, you're going to set it up as a compound. You take your inside of the absolute value, put it in the middle. You take what it is greater than and its opposite. The reason why it's written twice is because one has it with the equal to and the other one does not. Okay, so don't have to write both. Just write one and you'll be good. Huh? So basically, in other words, you're going to have a solution that is going to be less than you and a solution that's going to be greater than you. Okay. All right. Let's talk about it. Before we get started, we're going to go over just review some basic things here. Okay. First thing first, if I have the absolute value of 4 on a number line, that's saying that I'm looking for numbers that are 4 units or less away from 0. Does that make sense? Yes. If I have the absolute value of x is less than 4, I'm looking on a number line for values that are less than 4 away from 0. And that's why it goes from one end to the other. Does that make sense? So this is why you have a joint solution, because it can be in between. Okay, looking at it from a function perception. Here's your graph for the function. I have my parent function and I have my constant. So on your paper, graph your parent function and your constant. At the origin and then up 1 over 1, up 1 over 1, Tyler. Okay, parent function has a slope of what? Okay, so when you're graphing it, when you're here, it says, when is absolute value less than 4? So you're asking yourself, when is the graph, the function, below 4? That's what you're asking yourself. When is the function below 4? Well, the function is below 4 from here to here. Do we see that? And where does that fall between? -4 and 4. So that's why our answer is from -4 to 4. Okay. So your answer can be written as an inequality where x is in the middle. I didn't mean to put the equal to symbol there. -4 to 4, or it could be written as an interval again from -4 to 4, and that would be your solution. That means that I can choose any number between -4 and 4, and this will be a truth statement. Is 3 less than 4? Yes. Is 0 less than 4? Yes. Is the absolute value of -1 less than 4? Yes. Does that make sense? So I can choose any number on this interval and it will make a true statement. That's why it's my solution. Okay, that's our baseline. All right, now we're going to look at it solving wise. So here we have the absolute value of 2x plus 4 is less than or equal to 3, and it wants us to graph the solution set. Okay, if I am 2x plus 4 and I'm less than or equal to 3, the first thing I'm going to do is put 2x plus 4 in the middle, and I'm going to be less than or equal to +3, but greater than or equal to -3.
Oh, yeah.
Okay. So you set up by creating a joint inequality. I don't know what to tell you. Promise we did. Well, I promise you we did this. I can show you on Canvas. 4? 3 or 4. It was right before quadratics. I don't know. All right, here we go. So we need to get x by itself. What do I need to do to get x by itself? Subtract 4, and what I do to the middle, I have to do to the left and the right. So I'm left with -7 is less than or equal to 2x, which is less than or equal to -1. Okay, what's the last thing I need to do to get x by itself? Divide by 2. So therefore, my solution would be x is less than or equal to -1/2, but x is greater than or equal to -7/2. I said it from reading from the center in terms of x. X is greater than or equal to -7/2. X is less than or equal to -1/2. If you write it as -3.5, if it's a simplified, if it reduces completely, yes. But if it's an approximated, then you leave it as a fraction. Like if this was 1/3, no, you leave it as 1/3. Fractions are your friends. Stop trying to change them. Okay, no, I'm just saying it's a if it's a exact decimal, I'm fine. If it does not become an exact decimal, then leave it alone. Okay. On a number line. So if I was reading a number line, that means that I would be at -7/2 with a bracket or a closed circle. And any number between that and -1/2 would be working, right? I could choose any number from there, and this will still be a true statement. So I can also write this as from -7/2, comma, -1/2. Okay. Huh? Mm-hmm. And that's because it's equal to. I'm ignoring. All right. Huh? All right. Now we're on to greater than. Okay, so the greater than rule, again, you just need to write one of them down. It doesn't matter which one you write down. You're just going to write one of them. It's saying that when you're greater than, you're going to actually end up split. So instead of having a joint compounds, you're going to have split. You're going to have one where you solve the value of u, the inside of the absolute value is greater than its solution. Not its solution, the a. And you're going to have it where u is less than the negative of it. And again, the only difference between this one and that one is the what? The equal to sign. So that's why you don't have to write both down, because you're saying the same thing. Excuse me, same thing, just one has equal to. All right. All right. Are we ready to do an example? Here we go. Just make sure we have a baseline understanding of this. If we have solved the inequality, absolute value of, I forgot your graph, by the way, so just do a little sketchy sketch. I'm sorry. Absolute value of x is greater than 3. On a number line, I'm saying, where are the numbers that are further than 3 units away? Does that make sense? So on a number line, when I'm looking for the numbers that are further than 3 units away, it's going to be the numbers to the left of 3, of -3, and the numbers to the right of +3. Does that make sense? Okay. And so that's what it's asking you. So when we look at it as a graph, so here's our graph. We have our absolute value. You can just do a little sketch of however you want to sketch it. Doesn't have to be exact, because I just put a grid, like, X, Y axis. And You don't know how to draw X, Y axis. I believe in you. And then draw your V. And then draw your line and label.
What are we listening to?
We're looking for when is it greater. So we're looking for when is the function above / greater than 3. Okay, so looking at our function our graph that we have, I'm above 3 here, and I'm above 3 here. Does that make sense? So that's why my answer is when X is less than -3, because I'm going to the left of -3, and when X is greater than 3, because I'm going to the right of +3. Yeah? No one's like, this lady has never taught me this before. Well, I guess Gael and Deasia can technically say it. Well, no, I did try to teach Deasia this. I did. All right, here we go. So we have X. Our solutions would be X is less than -3, or notice here the key word is or X is greater than +3. And writing that in interval notation, it would be from -infinity to -3, or from +3 to infinity.
Oh, that's what you like.
Mm-hmm. It is. Okay, so it's an or situation.
That's what it was trying to tell me to do on my body was taking. I was just writing it exactly.
All right.
No fighting. Every part.
I'm quitting. All right, here we go. We're at 2x minus 5. So for this one, you're gonna create two. I'll turn that down. Further down, Gaia. You're barely going down, Gaia. All right. So here, when you are solving, you are creating two separate problems. So you're creating the first problem just by removing the absolute value bar. So you have 2x minus 5 is greater than 3. Then on the other one, you're going to do the opposite of everything. So 2x minus 5 is actually less than -3. The or is going to be the opposite. So instead of greater than the positive, it's going to become less than and a negative. And now you just solve for x. So we got whatever we got to do to get x by itself. What are the 2 steps we have to do to get x by itself? All right, do it. Y'all are dramatic. Oh, my pen. It did weird things.
X is greater than 3 times. X is less than -3 times. What? Oh, I forgot to add. Oh, I forgot to. Oh, I forgot to. Please don't get this over for you.
Huh? All right. So we did what you guys said. We're going to add 5 and divide 2. And when we add 5 and divide 2, we get that x is greater than 4 or x is less than 1. Make sense? Okay. Questions, comments, concerns? None? Okay. So that's what it would look like on a graph. All right, we're on to part C.